there. So then I decided, but I have to put another coil around the PVC pipe, because no transformer in the world works with just one coil, with just one coil on it. Even Tesla coils has got a primary and a secondary. So for my secondary, I used 1 millimeter magnet wire, and I wrapped 150 turns around the PVC pipe. Then I looped the two ends of the colored wire together, and I joined different colors. So in essence, I'm forming one long focus. Come on, man, focus. I joined the different colored wires together. So in essence, it's basically one long loop of wire going through the coil with a start, which is the brown wire going in here, and blue wire, the blue one, coming out here going to the transistor. Additionally, I took the green wire, which is not connected to the rest of them, but it runs along inside the coil, and I reversed it. In other words, I'm putting the input together with my brown wire, but flowing in the opposite direction, and the output comes back to my transistor, to the base of my transistor. On that, I've also installed a 1.5 kilo ohm, 1,500 ohms resistor to keep the voltage down a bit, and approximately 18 picofarad, no, 180 picofarad capacitor. Then on my transistor, I've got one wire coming out, which stops here, and that will go to my negative of my power supply. My input, or my positive from my power supply, I've connected 1, 2, 3, 4, 5 ohm resistors in series, which means if I connect my power supply to any one of them or in between them, I can actually step up the voltage and amperage input, or I can step it down. So yeah, this is my first explanatory video about this whole thing. I hope you enjoyed it. Please like and subscribe.
All right, guys, I'm going to give the link one more time. This is absolutely fascinating because it's like our coils, okay, in some ways, and in some ways it's not. So I just really enjoy when people do things a little bit different, because the permanent magnets in there causes either compression or it'll cause it to, change the energy field in a different way. But then the two energy fields he's getting from his inner coil and outer coil is absolutely amazing.
Yeah, that's wild. That's very creative. I'd have to watch that a couple of times. A lot going on.
Yeah, I'll put the link in the description right now. Yeah. it's just I love the fact of how interesting it just because of fields. I like to play with the fields, kind of like you guys do, and to see which one does what. And then when you amplify one, what happens to the second one, and then how do the permanent magnets in there, are they swirling it? You know what I mean? Like you would get conventionally. Are they compressing that center field so there's always like a magnetic value on it? Like if they're, you know what I mean, repulsing each other in the center, or if they're pushing away.
Yeah, you're definitely mixing a lot of magnetic fields. There's definitely pressure going on.
This is him right here. He says he stays away from high voltages. He has a pacemaker. I would definitely stay away from high voltages. People of Planet Dreamscape. Oh, hold on. Greetings. Whoa, what's going on there, dude? Who's messing with my system? All right. You guys want to see that video?
Yeah.
Hello? Is anybody awake?
Hello?
What's up, guys? What happened? Who's messing with your system?
All right, guys. I'm going to put it on, okay?
Can you hear me?
Was that guy
Yeah.
trying to debunk that coil as a free energy thing, or what was he doing there?
Oh, no. He just puts it out that it's not a free energy device, that he's just doing research on it. He's not trying to make any claims. That's all.
Oh.
So, yeah, but guys, check him out, man. I enjoy watching it. So, anyway, all right, here's the new one, guys. Not the same as last week, but here we go. We ready, Shawn? Shawn out to lunch? All right, well, I'm going to play it anyway. Starship Fringe Thing. Rewind
Is
it.
this a new one?
Yeah, it's a new one.
Is my mic working?
People
Oh, it
of Planet Dreamscape, greetings from the Starship Fringe Think Tank.
Welcome to the Plant Dreamscape.
It's an honor to meet you, Gold Lady. We'll be transporting down to the surface in no time.
I must warn you, Captain. Any random thought during transport may have unexpected consequences.
Gerald, gather the away team and meet me in the transporter room. Guys, try to be on your best behavior. That Gold Lady seems like one of those uptight scientist types.
The elite of the most prestigious scientific communities.
Gerald, I don't think that Gold Lady's gonna like that.
There you go. Well, when it comes to women, as me dear departed father used to say, you can't live with them, and marrying's illegal.
You know, there was something I was supposed to remind you guys about. Something about random thoughts. Huh, oh well, we'll just figure it out when we get there. All right, Ian, 5 to transport.
Nathan.
Oh, that's a good one.
Oh my God.
This didn't work out for us at all. Oh man, have you guys seen Bernie?
All right.
It's gonna be so great.
Bernie's a scarecrow.
Ben, where was Mike? Isn't he usually running the transporter?
Right. So now put one prong in the ground, the other prong in the smaller hole, not the bigger one. The smaller.
Does it matter which one is which?
You know, that's a tough question. It kind of does matter. But anyway.
Wait, so the red
Of the two holes, other than the ground hole, of the two holes that you have there, one is smaller. That is the smaller hole is the power. The bigger hole is the return for that power.
the negative. Okay.
Yeah, you don't want to use that.
Oh my Jesus. Oh. Every time we check on Mike, he has the same conversation. It's hilarious.
I like that Wizard of Oz photo. That was funny.
People of Planet Dream. Hold on, I'll put it. So we got Victor in there, right?
Well, that was a short
Oh
one.
yeah. Yeah.
I couldn't get a good picture of his face because he's always in the dark room. So, just
It was
Gerald.
a challenge, I know.
Gerald talking Irish, man, was just the most hilarious thing when you did it on the show. So, but everybody's random thoughts. So Gerald is thinking of a lion. Then Ben's
Oh, I
thinking of
didn't see
Leonard
that.
Bot over there.
Yeah.
And then Bernie's thinking of popcorn. And then I'm thinking of a gorilla watering his lawn, but it looks like he's taking a piss. And then we show Victor over there thinking of wizards. So
Wizards.
I wonder what Ian's thinking about. He's got a big smile.
because Gerald's talking Irish.
Who's the lion that's all naked?
That's Gerald.
Oh, good. Gerald
Remember the
lost his
lady
pants.
said, whatever you think about's coming back to, you know what I mean?
Yeah, these are funny. These are funny.
What
I'm
are
all
you using
fat.
to make this?
Oh, I'm just, oh man, I'm using, what was it? Search of the Sea.
Standard photo editor?
Canva.
Canva.
Oh
Yeah.
yeah, I use Canva. It's great.
Oh, it's just funny.
Canva and
I-
a website called remove.bg. It'll remove backgrounds pretty easy too.
I just love it. We can't have any of this, Mike, without you. So I always have to add you no matter where you are.
I want to learn how to do animation cartoons.
Yeah. No, I was I'm gonna when layoff season happens, I'm gonna start Blender. I'm gonna start learning a little Blender, maybe putting some of those in the videos.
Oh,
And some 3D stuff.
I
Yeah,
looked at a
animation
lot of
would be
those
nice.
AI,
Learning it.
animators. None of them seem to animate right. It's like,
Yeah, I mean, honestly, you really have to either hire somebody or learn how to do it yourself. And I mean, there's maybe one or two pieces of software that I use to help me, but it's still hit or miss. I'd like to actually learn how to properly animate everything.
I wonder if the cartoons like the Simpsons and all that, was that like hand drawn and then scanned one frame at a time, or how did they make that?
I'm not sure, but I know South Park, they have their own custom software for animation, and it works quite well, but it's proprietary. So,
yeah. So anyway, guys, I hope you enjoyed it. Just another episode. I'll put it in again. And then if you guys want it, man, just let me know and I'll send it to you.
Is it the HD version?
Yeah, the original version. You can change it all you want. I like Mike's version. I watched it today. He's got the beeps and bops of what's going on in the Star Trek show. It's pretty cool.
Yeah. Found it online.
Right on. Yeah, well, captain of the Star Trek French think tank. Oh man, that's so great. Yeah, well, I don't know what happened to Gerald, guys. He was here, and then his thing popped off, and I tried to email him, and I haven't got a hold of him yet. So,
I hope he's okay.
Yeah, I hope so
Internet's
too.
probably crap. His internet's probably just down, maybe. Oh, there's Bernie. Yeah, Bernie's having a problem with his internet, looks like, too. He's popping in and out.
Yeah, I've seen that. So I think everybody's just having a little trouble. I hope those cats didn't pee on his router again for Earl. Oh man. All right. Shawn, you still there? I think Shawn took a break.
Shawn's at the fridge.
Right in the fridge in the middle of the show. Nice.
So, Mike, you were asking about a high voltage LED. I knew I had a couple that came with my Tesla coil, and I just found them. So, I also have an update from Mike Morrell about his developments on the coil. And he actually utilized one of Daniel Nunez's modified Joule Thief circuits, which I'm going to be building tonight at some point and testing out. And he got some really good results. So if you want, I can show you.
Hi, gents. I'm back. Thanks for the break.
Right on. Did you see the video?
Just parts of it. But I did start laughing at something about a cat and a router.
Gerald disappeared on us again, so I think his cat's got his router again.
Too funny.
Oh,
So I caught part of it, how he was mixing electromagnetic magnetism with permanent magnetism with he had some voltage drops, and I mean it was a lot to take in.
I was referring to the other video.
Oh, no, I haven't.
Oh. I think
Oh,
Bernie's
my.
trying to say do it again. All right, one more time, Bernie, just for you. Planet Dream. People of Planet Dreamscape, greetings from the Starship Fringe Think Tank.
Welcome to the plant dreamscape.
It's an honor to meet you, Gold Lady. We'll be transporting down to the surface in no time.
I must warn you, Captain. Any random thought during transport may have unexpected consequences.
Gerald, gather the away team and meet me in the transporter room. Guys, try to be on your best behavior. That Gold Lady seems like one of those uptight scientist types.
The elite of the most prestigious scientific communities.
Gerald, I don't think that Gold Lady's gonna like that.
There you go. Well, when it comes to women, as me dear departed father used to say, you can't live with them, and marrying's illegal.
You know, there was something I was supposed to remind you guys about. Something about random thoughts. Oh well, we'll just figure it out when we get there. All right, Ian, 5 to transport.
You put Ian in a quilt.
Nathan. Oh my God.
This didn't work out for us at all. Oh man, have you guys seen Bernie?
All right.
It's gonna be so great.
Ben, where was Mike? Isn't he usually running the transporter?
Right. So now put one prong in the ground, the other prong in the smaller hole, not the bigger one. The smaller.
Does it matter which one is which?
You found a perfect sample. That's a tough question. It kind of does matter. But anyway.
Wait, so the red
of the two holes, other than the ground hole, of the two holes that you have there, one is smaller. That is the smaller hole is the power. The bigger hole is the return for that power.
the negative. Okay.
Yeah, you don't want to use that.
Oh man, that's absolutely hilarious.
Love it.
Oh, it's always funny. Mike's in the lunchroom and still thinking the same conversation in his head. Oh, we're gonna have to keep doing this, guys. That's too funny.
It is. It's great.
Oh,
Too much fun.
we'll have a little mini series before we know it.
We get Shawn in there at the helm, running the laser spark, shoot at the Ferengis.
Yeah.
Oh man,
Laser. What do they call the tractor? No, laser beam.
Phasers or tractor beam.
Phaser beams.
Yeah, the Star Trek guys carried phasers.
No, the ship has a laser gun.
reflector dish.
I think it's phasers too.
Yeah. And it has those what do you call those other things? Those timed bombs or whatever.
Photon torpedoes.
There you go.
I'm not a Trekkie though.
You are now.
Photon torpedoes. Load the photons. Was it photons? Yeah. Light bomb. It's a light bomb.
Oh.
Yeah. All right. Great old show.
What has Star Trek not predicted I mean, they probably even predicted the light bomb. You know,
Yeah,
the photon torpedo, whatever, the light torpedo.
something with no mass being an object of destruction sounds interesting.
No, well, light has mass, energy mass.
For some reason, they say photons have zero mass. That's why they can go as fast as they do.
It's got to have mass. It's got energy.
Yeah, that's the
They keep
standard
changing it every
model.
year. It's something new. Like just this year, they saying that the Big Bang was not the first event, and there was a bigger explosion before that one.
Yeah, you know why the Big Bang is crumbling is the James Webb Telescope. It's allowed us to use infrared, and it's 1,000,000 miles from the Earth, so it's in a real dark spot where they can see through all the dust clouds. And they were expecting to see some kind of primordial part of the universe where just right after the Big Bang, they were going to see, old type, what's the word? Just the beginnings of the Big Bang. And what they found was perfectly formed galaxies and stars, just like we see all around us today. So now they're like, oh boy,
What?
James Webb can
What?
see.
Did you just say what I think you said? Before the Big Bang, they found perfectly formed galaxies?
Sorry. So they're supposed to see so deep in the universe that they're going to see just after the Big Bang. And so they wanted to see star formations and galaxy formations that were primitive, because now we live in like the Milky Way. These are more advanced, complicated.
Instead, they were all already formed.
They were just as good as informed and complicated as everywhere else.
And
so now
how did they
they're
even see
rethinking
that?
it. So the further you can see in the universe, the further back you're looking in time. Because let's say you're looking back.
I mean, my question is, how could they see past the Big Bang? You know, that shield or that energy wave.
I've not heard of two Big Bangs. That's probably very new. I just know that the Big Bang's falling apart because they were hoping to see a lot of their theories.
So they're not seeing through the Big Bang. They're seeing through something else.
So they're not seeing the Big Bang, but they're seeing further into the past. And all their models show that there should be certain things, and none of it is what they're thinking. So also, too, there's a really good new theory on gravity that's coming up. And what's hilarious is, what's that?
Yeah, what's your understanding of that new theory?
Well, I just heard it yesterday, so I won't do it justice.
Okay.
But I can say
what did you get out of it?
What surprised me was that a guy tapped into 0 point energy. And by the way, this is a prominent academic physics and physicists, and they're not the fringe scientists, but this, as the standard model falls apart or looks ridiculous, quantum mechanics and so on, there's a new theory that can link the small to the big, which has always been the problem.
You see that what Quatrin just wrote? We're in a brain. That's a.
Are you talking about a Boltzmann brain or Boltzmann?
He's saying that the whole cosmos is inside of a brain.
When they say brain, they mean like membranes. So if you could think about a room with a bunch of rubber curtains, and if you pass one rubber curtain, there's another rubber curtain. That's what they mean by brains. It's BRANE.
Layers.
Right.
So wait, so they got this James Webb out there now far enough, and they got it up and running so they could see further than they could see before. So essentially, the furthest that we could see in the past was considered the Big Bang beginning.
Yeah. So.
And now that we can't see the actual Big Bang, because they had some kind of reading of an image of the Big Bang that they presented to the public. I don't know. Looks like a big globe. bluish colors and kind of like the TV static, but not.
Oh, you're talking about the universe's microwave
The Big Bang
radiation.
signal. That's what they called it.
It's
that image.
leftover. It's leftover microwave radiation from the
That-
Big Bang.
Right, there you go. That they said was from the Big Bang.
Correct.
And now they're saying that it's not from the Big Bang, but
Thank
they
you,
still have
Victor.
the
What's in brain?
radiation background thing. And they don't have an answer for that. Now they're just going to abandon it. Oh, the radiation background doesn't exist anymore. It's still there.
They're just so. My daughter is a physicist from Northwestern University, and so we go back and forth. And one thing she told me was that there are a lot of infinities, a lot of assumptions in designing the standard model and our basic understanding of cosmology and the universe. And she always wondered why there were so many assumptions that it can go different ways, and it started to become smoke and mirrors to her. So I guess it's not too difficult to incorporate these new theories as long as they can get some experimental evidence.
I just hope that image that they called the leftover radiation of the Big Bang is an actual real reading. And if it is, why do they navigate away from it? It's got to be part of this whole, telescope thing that they're seeing past that radiation layer now. They're seeing past that particular, is that what we're saying here? That they have able to see past that particular radiation layer, or they're just seeing further than they've been able to see before?
That's a good question. So we'll start with the background microwave radiation.
Because they're not using a telescope to see the radiation. They're using other instruments to do that.
Right, correct. We have radio telescopes that just see with radio signals. We have every kind of telescope. So they just call them telescopes, but you're right. They're not the see-through and the visual.
They're not lenses per se.
Correct.
Okay, hey, Shawn, I think I found the resonance frequency of this thing.
Oh, you did?
Yeah, I think I'm on it.
Awesome.
I mean, I'm not sure how that James Webb was it. I don't even know how that lens is, if it's even glass or what technology they're using to do that.
It's about the size. The lens is about the size of a tennis court, and it's a bunch of beryllium, I think, gold-plated octagons or hexagons, and they arrange themselves to make one giant lens.
That's interesting.
Nathan's got something. We're ready to go.
Sounds like they had to launch a bunch of times to get all that stuff up there.
I can tell you facts about it, blow your mind. It's so crazy.
I don't follow this kind of stuff. I don't know why. I'm totally interested in it, but I don't dig into it. I don't know why. It's busy with other things.
Yeah, I mean,
I just
everybody
think
has
they
their
should put it
interest.
more publicly out there and more available, like, people to know what's going on in the latest, developments of technology in general and discoveries, instead of proprietarizing it all into shows and that they can sell to cable subscribers. It should be public information, like right away, not later.
Well, I've been waiting on the James Webb telescope for about 18 years now. So I just been so interested in the new telescope that is going to replace Hubble.
Yeah, I kind of gave up on all that waiting. I'm 50, so you're 50 something.
I'm
and we're in the
54.
same- Yeah, so we were in our 20s sort of when they started launching these telescopes, and we were given the hopes of, and those hopes came true to a large degree, over the next 20 years of all the imagery they gave us, and all these things we were able to see now that we couldn't see before.
Yeah.
And it's not stopping. That's the whole point. It's not. That's the crazy thing. They're advancing. It's not seeming to have an end. So
No, there's too much to know. There's a lot of cool stuff out there that we're still just discovering. So
I would like to know what kind of instrumentation they use to detect the background radiation.
probably microwave radio telescopes. They're these giant dishes. They're like 200 feet in diameter.
Oh, that's right. It was microwave background, right?
It's what microwave background radiation. It's so puny low that only a sensitive instrument and can detect it. And they construct this sort of oval-looking. You've probably seen
microwaves are all super high frequencies, or do they range? Or
okay, definition: microwaves are in the gigahertz range.
Hello, hey guys.
So is it
Hey,
steady,
Nathan.
or
It's fascinating as all that stuff is, guys. John, I need your help real quick.
Who, me?
Yeah.
Okay, what's up?
So I need you to look at the numbers here.
Escape.
Greetings. All right, I've had enough. I've had enough. I don't know how that thing. Now it's gone. Okay, now here we go. I have 21.46 on my volts.
Uh-huh.
And I have 1.037 on my amps.
Okay.
And a resonance frequency of between 306 and 310. So I'll call it 308.
Yeah.
And I got light up at about 2.5 feet out. And I do have breakout. We're in DC.
Yeah. The quasi-continuous wave. I see it. What's your voltage setting? Is it 22 volts?
No, it's staying steady. It's
what was the starting voltage that you started with?
I started right there.
21.4? You started at 21 point?
Yeah, it's only going to go up on the second decimal point. It's fluctuating.
Can you see? Okay, so you can't put an even number in there, like 20 volts.
Hold on, let me see. Just give me 1 second.
Sure. I mean, your amps look like in a safe range where it is oscillating. If you recall, as long as the voltage is steady and the amperage is in that 1 amp milliamps range. Look at that, it's 0.9 amps right now. 20 volts.
Yeah, voltage is steady.
Yeah, it looks good. So what you're seeing here now is your voltage is steady, your current's in a decent range, and you got a breakout on the top of your Tesla coil. So but because the breakout is not huge, that's the room you have for tuning. And so it's not necessarily that you're tuning to have a huge breakout. Huge breakouts are great, but you're more in tuning to see how efficient you can get it to run, because then you'll have a lot of plasma at a very low power, and that opens you up for other experiments.
So do you think the setting is just a little bit off?
Yeah, I think so. Are these the same capacitance you had for your other ZVS?
Yes.
Yeah, so I figured that the capacitors wouldn't work 100% because it's a new ZVS board. It has a newer design, has less diodes, has less resistors. So the new ZVS is not quite going to work like the old one that you had tuned. And so what I would do is, so for example, what was good resonance that you were picking up on your O-scope when you were using the old ZVS? What was the frequency?
You would set it at 307, and that's in kilohertz. And then it would drop once it started resonating.
But so when you connected the little antenna to your O-scope probe, and then you turned on your Tesla coil when you're getting those 10-inch sparks, what was the antenna picking up on your O-scope for frequency?
That's what I just said. It was about 307.
307?
So we're just a little bit off right now.
What are you picking up now?
Sorry, you can't really.
No, it's cool.
That's a nice clean wave.
It is. You're getting 310, and so that's
We're
That's
just a
a
little
CVS
little
making it?
off.
yeah. I mean, I
Well,
yeah.
you guys go ahead and talk, and I'll adjust it just a bit more and see if I can't get this thing up.
Sure.
So I looked at the ZVS circuit. It's got those capacitors. That's what helps the wave build and drop slowly, like that. And it also, they use a flyback to trigger the next pulse or whatever.
It's not a flyback. It's a tank circuit. So if you connect a capacitor and an inductor,
No, they're not. I don't think they're using the capacitors as tanks, even though it can be. It's
they're
filling
used as
up
tanks.
slowly, but yes, it does pulse, right? But I think they're using the flyback, the opposite direction, to trigger the next event in the next pulse in the ZVS. But the capacitors are there, so the voltage rises slowly, and you get that sine wave curve.
So
And so that you also get the same drop slowly. And that's from those capacitors. The two capacitors. One capacitor handles the top half of the build of the sine wave, and the other capacitor handles the bottom half fall, or I don't know if you'd call it a fall, but yeah. And it keeps the voltage rise and fall even in a curve fashion, so you don't. And it also prevents it from creating spikes in that way.
So you're sort of describing more of a
but there is a
traditional-
flyback pulse. It's not a spike per se. It's
No,
a
it's-
smaller pulse.
It has nothing to do with flyback. Sorry, I think you're talking about something else, Mike. So you have
The
two
ZVS has coils,
MOSFETs.
correct?
You have two MOSFETs. When you apply a voltage, because there's no two perfect
You
transistors,
got more than two MOSFETs.
one of them
in there.
turns on.
You got a lot more than two MOSFETs.
There's only two. When you turn one
No,
turns
I mean,
on,
there's other components other than two MOSFETs. There's coils and there's capacitors.
those round coils there are chokes. That's just for a ballast to make sure the
Right.
current is steady.
Yeah.
The capacitor, the two capacitors form a tank circuit with the primary of the Tesla coil, and that creates the oscillations that then resonate with the secondary of the Tesla coil. And when it reaches the resonant frequency,
That's what I was saying. Your oscillation has a curve.
Sure, but it's not a rise and fall time by capacitors. That's more of a
Yeah,
power
the
supply.
capacitor controls that steady rise. Isn't it powered by DC or AC? I can't remember.
In a power supply, you're correct, but not in a ZVS.
Is it powered? Is the ZVS powered by DC or AC?
Both. You can choose which one you want. The only thing is the AC, you have to filter out the negative part of the sine wave.
Mm-hmm.
So if
Why do they rectify out that half? To make the DC pulses. Okay, gotcha.
I rectify it out because I like the cool sparks.
Well, they get a DC pulse when you do that.
Exactly. It's only the positive, so it actually stops and then
Right,
pulses
and where's that DC
positive.
pulse going? Into that choke coil.
Correct. The chokes are prevent from large current spikes and blows up your
Right,
ZVS.
and it also enables them to get a lower voltage that they can use to trigger the next. I don't know if it's pulsing or oscillating, but I think it's depending on if you're using DC or AC.
It's oscillating. It's not pulsing.
Right, if it's oscillating and they're using AC, so then that coil is still being, the AC is still being clipped, right, on the way in.
It just resists changes in current, so
With
your
the diode?
current's going to be out of phase from your voltage because it's going to cause a lag.
The diode is the AC being clipped on the way in?
No.
Oh,
Oh,
see, I've
it's
never
a-
worked
oh.
with a ZVS, so I just seen the circuits, and they look very interesting.
I've been looking for a high voltage oscillator for a long time, and this is, I think,
Tunable.
yeah, I think it's the great.
You change your cap size to, to change your signal.
Exactly. So the steps to get your ZVS working is you measure the inductance of your primary coil, and then you take the secondary coil. These are of the Tesla coil, and you determine its resonant frequency. So that's a separate bunch of steps. And then once you get the resonant frequency of the secondary coil and the inductance of the primary coil, then you can put it into a calculator on the internet, and it'll come out with your capacitance needed. And so those are the steps. And so I'm going to be presenting on these steps. I'm going to try to simplify them so everybody can build their own, I don't want to even say Tesla coil, but their own high voltage plasma. And it doesn't have to be dangerous. I shared with you in the presentation that I was only using 7 volts AC, milliamps. And yet I got 2-inch sparks, and it was fun, and I can experiment with it. So, but yeah, those are the 3 steps. 1, inductance of the primary, which is that copper pipe. 2, the tall tower of the Tesla coil, which is called a secondary. You get the resonant frequency of that, and then the calculator will spit out your capacitor size. Once you get that capacitor,
I think the capacitor is there to help, because you're never going to get the 2 coils exactly right just to have them resonate without a capacitor. You need the capacitor to make up for that small amount of difference.
It's the key component. Otherwise, you can't get resonant frequency. When the capacitive reactance equals the inductive reactance, they cancel each other out, and then you get, well, on paper, you get infinite current. But because there's no perfect capacitors, inductors, or even the wires have resistance in them.
Yeah, because when they cancel, it also seems to simulate the removal of resistance.
It doesn't simulate, it does. It removes resistance.
Well, it's all the amps that flow like crazy.
Right. And so it's what is called a
but that's only when they're canceling, right?
Correct. So think of think of a capacitor like a resistor. Okay, so if capacitor 1 has 100 ohms, and by the way, capacitive reactance is measured in ohms, just to make it confusing, but so let's say the capacitor has 100 ohms of reactance, and then the inductor has 100 ohms of reactance. Well, their reactants are 180 degrees out of phase. So boom, they cancel each other out. Boom, you have it.
Oh, right. That's a good way of putting it. I didn't look at it like that. Right. That makes sense.
And that's the cool thing about the ZVS, because that's what I don't know if you caught the part of my presentation where I grabbed some balls of wire out of my used wire bin and built a primary secondary coil that oscillated.
Uh-huh.
Did you catch that part?
What, today's show?
Yeah.
I was half an hour late.
Okay, yeah. I'm taking balls of wire out of my junk wire bin and throwing them on the ZVS, and they oscillate because the ZVS is, I think someone said here in the chat, ZVS is the new kid on the block. Oh yeah. It's strange how it's so powerful.
I gotta say, I do, between 2 pulse systems, the ZVS and just the standard switch of a coil, I like them both, and I don't think either is going to go anywhere. They're very important, because one is, you got capacitors there controlling your rise time and your fall time, and the other one doesn't have any of that. It's as sudden as possible, the switch,
So you're talking about power supplies again. I think you're talking about power supplies.
Switching wise,
Hello. Okay, Shawn, remind
Yes.
me real quick. I know you guys are having fun. I want to go to AC now. So, which wires go where? The two diodes go to the negative or positive?
Two diodes go to the negative, and the cathodes are faced away from the variac.
That the half bridge rectangle, whatever, full bridge rectangle.
It's a
I
half
need to get a
bridge, you're right.
variac. I don't know why I don't own one. They're just too cool to be able to vary AC like that.
They're cheap and they're awesome.
Yeah, they
for
are cheap. I
200
still
bucks.
don't have one. It's ridiculous. I mentally smack myself over this thing. And I had a lab for like 4 years, never got one. Just
Yeah.
could have
Go
been
on
making all
Amazon.
kinds of DC or an AC or whatever.
Yeah, it's awesome. Yeah, you can build your own rectifiers and clean up the AC, make a DC. Get a 30 amp.
It might have something to do with the fact there's 120 volts in the wall already. I don't know.
All right, guys.
You
Hold
settle
up.
for the 120, but if you want a lower volt AC, that comes in handy.
Yeah.
All right.
How's it going?
So, all right, you ready? I'm
Wait,
just gonna
wait.
barely
Wait,
turn
wait.
it on.
Wait. The cathodes, are they pointing away from the ZVS? Cathodes
What?
pointing away from the ZVS?
You mean the power?
Yeah, they're
The-
like under 50 bucks
The
now.
diodes, sorry. The diodes, are they the cathodes pointing away from the ZVS? How about this? The cathode on the diode needs to be pointed toward the variac.
Okay. Well, you lost me. Where do you
Okay,
want
the
this
gray
thing
ring.
sitting?
The gray ring on the diode. Can you pull it up? The gray ring.
Yeah,
on
those
the
are
diode?
set exactly where you set them.
The gray rings are away from the ZVS.
Yes.
Can you-
Yes.
Okay. Awesome. I just didn't want you to fry something. Okay.
Hold on. No, they're not, because one side's away and one side's towards it. You're talking about
Not on
these, right?
Not on the board. Do you know the diodes that power from the variac?
Okay.
Go to the variac, pull the wire until it comes up to the ZVS. Are there diodes in between there?
Yeah, it's just the way
Yes.
we set it before.
I just
Why
want to
did you
make
say that?
sure.
Yeah, I got it set the same way.
Gray rings are down.
Yeah.
Okay, perfect. Sorry, I just didn't want to see you fry it.
No. I kept it the same way. I don't touch that. So we're hitting 10 right now. Let me just point it so you can see this.
Oh, beautiful.
So I'm going to go up to 20.
Your primary doesn't look stable.
We're not in resonance then?
It just needs some more tuning, because do you see how it's blinking on and off the back signal?
Yeah.
That's your primary. The squiggly line that gets bigger toward the right, that's your secondary. It's resonating.
But it's not
just
in tune.
resonating. It's not in tune.
Okay. All right. Well, that's fair. So I need it to be very clear on the signal then, right?
That's one way to do it. Another way you can do it is, remember I told you the volts peak to peak? If you're
Okay.
looking on your the screen of your oscilloscope, there's frequency, there's voltage peak to peak. It's called VPP. You can look at that, and as that number goes up, you're getting closer to resonance.
Right.
Or a simple way is, as you start to lower the capacitance or raise the capacitance to tune it, just look at your breakout. If you're getting bigger sparks, you're doing it right.
So do you want me to go back to DC or stay in AC?
I mean, were you getting a breakout with the AC?
Yeah, I get a breakout with the AC.
Yeah, I mean, let's stay with the AC. I'm curious. So Are you looking to talk about some of this? I'm sorry, I'm lost.
Shawn, you're here. I got a Tesla coil. We need to tune it.
Oh, I see. Okay.
I mean,
Let me
I
let me
get it.
let me
Eh,
say a little bit here to Nathan. So Nathan, get it
I'm
running,
here.
put it on voltage peak to peak, like Shawn said. Slowly turn it up until you get your maximum peak to peak voltage, and keep turning it up until that peak to peak voltage starts to decrease. That's when you're going out of resonance. Then you want to back up to where it made its peak. Its maximum peak is resonance,
No, I
So-
understand that.
so long as it doesn't blow. Then you
So
have resonance.
thank you, Mike. It's close to that,
Maximum
Mike.
peak to peak is resonance.
It's close to that, Mike. Thank you for that. So when the capacitor and the coil 1, the primary, they oscillate, okay? They need to oscillate together to make coil 2, the secondary, to resonate at its frequency, and then that's when you get the big plasma discharges.
Okay.
So,
All right.
yeah,
I understand the theories. Okay.
okay.
I
Mhm.
don't need that right now.
Well, yes.
We are simply putting a wire in a different direction to see where it oscillates. That's the only point we're at right now.
Resonance. You want resonance.
Okay.
Are you talking
You
about
need to
putting
tune
the
it. You
wire
want to
down
tune
the
it,
center?
right? To tune it, you need to tune it to resonance.
Okay, listen to
That's
me.
your tuning.
Just stop. Listen to me. The only thing we need to change is where the wire is placed on the number 1 coil. Then we can find resonance. Now, the oscilloscope is a tool to get there. All I need to know is very clear direct information, not any theory.
Yes,
I'm
correct. The
trying
oscilloscope
not to
is
give you.
your guide to see resonance better than on the screen. In a reading by the peak to peak is how you see it. The maximum peak voltage that you get out of this system is your resonance point. Whatever you can tune it up to get the highest peak voltages, top and bottom, the plus and minus on your signal, and keeping it steady and clean, that would be resonance.
So
But
so
you want to slowly
Nathan,
turn it up, slowly.
Nathan, you still
Yeah.
got me?
Yeah.
Are you looking to move the alligator clip on coil 1 to tune it? Is that what you're saying?
Yes.
Yeah, apologies. I thought you wanted me
that's
to do the
something else.
capacitive tuning.
No, because I can't because I don't have your little meter, so I have no idea how that works until I can get that.
Gotcha. Okay,
So I have to do old school, move the clip.
no worries. The good news is you're close. So, does the clip just have on the input and the output of the primary pipe? Or is your clip in a certain spot on the pipe?
Okay, hold on.
Shawn, what's the clip? Is that his ground or something?
It's the primary connecting to a tank coil to the primary capacitor.
Hey, can you see it better?
Yeah,
Hold
I
on.
can see it.
Okay, you see it here?
Oh, it's like a signal.
The other one's connected on this
Yes.
side. So we're
Mhm.
connected correctly. It's just not in resonance yet.
And can I see your breakout? Just to see how far out of tune it is. You put in like 40 volts. Can you put in 40 or 50?
Yeah, our breakout's terrible. Hold on. I can't run that. I'll blow them offset again.
Yep. Okay. Should have a little fan down there.
Oh, hold on. I might have a. Just give me a minute.
Sure.
I was trying to tell him to get a nice thick piece of aluminum and use that as his heat sink.
It might help if I connect the ground.
Oh no. That's good feedback for no ground. I don't get feedback without ground. Dang.
Okay. Now. No, we're out. Okay.
Okay. Is your red light steady? Is your red light blinking?
I can tell you right now we're way out of it.
It sounds out.
Yeah, it's way out. Lord.
And you're yeah, I think you fried a diode or a
It sounds like a
MOSFET.
transistor switch gone bad. Yeah. You hear that snap? That
No.
Yep.
We're out of resonance. That's it.
Okay.
It's okay. Yeah. All right.
Okay, turn it on low and show me what your oscilloscope on a probe says when it's turned like 5 volts AC. Just something small where it doesn't fry anything.
I wonder if they have an oscilloscope that hooks right up into the computer so you can just directly share the signal on the live streams.
Yeah, it's still all over the place, Shawn.
Yeah. Also, too, the squiggly line in the middle is flat now, so it's not, your secondary is not resonating at all.
Yeah. Okay. Well, I guess I'll have to go back to the drawing board and fix this thing up.
Nathan, if you want, we can do an offline StreamYard and we can just go through all this step by step if you're cool with that.
Well, yeah, usually, look, I could find it pretty easy. I haven't had time today, and it gives you guys an opportunity to help out and figuring this out, right? It's just a lot of cross information, and it does nothing but frustrate me.
Yeah. I'll be quiet next time. Sorry.
Oh, no, it's not that. It's when all you have to do is move
Nate.
one wire, all the theory
Yeah.
in the world, you could take that, throw it in the trash, okay?
Nate,
But when you're moving
How
one
much are
wire,
those
you just
small
need to have
parts?
somebody who understands it in a feel way. You know what I mean? Or you're hitting it right, or you're getting there. You move it left, move it right. You know what I mean? That's it.
Yes.
how hard is it to change a MOSFET on a ZVS? It can't be that hard, and they're cheap MOSFETs.
Yeah, if you got a bag of them, it'd be great. I could blow them all day, but I don't.
They're like, what are they? $2 in each or something? Like
Yeah,
a
hold
couple
on.
bucks. They're high amperage though. The thing is, if they get hot, even though they're high amperage, they're still going to go bad and still run, but they're not going to run great. And that's what fools everybody. It fooled me for at least a year. I was having with one of my oscillators or whatever. I was wondering what's up with this thing. You know, wasn't performing like the other ones. You know.
Are you referring to what?
It was it was just a bad transistor that was partially working, or let's say it was 90% good, 10% bad. That's all it takes.
Was it a
could just be-
MOSFET?
Yeah, and they'll run and run and run, but they'll run, deficient. Like they're not switching right.
Mhm.
People don't realize that they're not switching evenly. You're not getting an even spread in your pulse or whatever signal. And that's what it is, and but they'll run, and you think everything's fine forever.
I've not run into that, but thanks for the tip.
Yeah, I've put together probably 24 pulse motors, and just they're all in parts now, and had them all running all at the same time, and a couple of them would just at a time would just be like not running that well. You see, like it took a little bit more time to start up and all that stuff, and I got the feeling that something was up, with the switch, itself.
Yeah.
So I started just changing the transistor, and bing, the thing's running like healthy again. From there on, I was like, I didn't even doubt it. Next time I had an issue, I just changed the transistor. I don't even ask questions. I've been an electrician for 30 years. I can tell you I've changed wall switches in the thousands.
I might have to go back in the
customer
video.
says my light's flickering, I don't ask questions. I go change the wall switch.
Yeah, Shawn, you had a method of testing the MOSFETs, and I have to go back because I missed that part of the video.
Yeah, it's a small meter.
They're cheaper than regular wall switches.
Yeah, it's a small meter on Amazon, and it has an auto function, so it'll test your MOSFETs, transistors, diodes, and everything. So it's pretty cool. Yeah, are we connected over Facebook Messenger? Oh, I can email it to you. I'll email it to you.
Yeah, I have a Facebook Beneficence TV page as well.
Okay.
I'll put that in the chat.
And then, I didn't want to keep changing these transistors, so I started putting, insulators and heat sinks, and I was running them without any insulators or heat sinks. And you know why they kept going back? 'Cause they kept touching it while I'm grounded and stuff. I think that's
Oh, but
why.
I do have some updates on Michael's coil if you want to hear about that, if we're looking for something to talk about.
Yes, please.
All right, let me pull it up. All right, so I'll read you what he wrote me, just to describe his setup before I play the video. Give me 1 second. Circuit. I'll make sure I have it downloaded. Okay, good. All right, so he said he was playing with the Daniel Nunes old circuit, the one with the transistor. I guess it's a modified Jewel Thief circuit. It's the one from the video that we see in Randy's Donuts, the documentary. And I'm sure there was a longer video on YouTube that probably got taken down, but this is the only clip that I've managed to see of it. And it does quickly show the circuit. He takes the coil and he hooks it up to one of those big antennas, those old TV antennas we see on the roofs of some houses and buildings. And he uses that circuit and kind of rectifies the signal into usable power. And he's using a potentiometer to, tune into the right frequency for the coil.
Oh, wow.
Which is pretty cool. Yeah, so you see like a little flash of light. And so what Michael did was he used that circuit, and he said he was at 1.25 kilohertz, using 15 volts and 220 milliamps and getting 200 volts output, just like what Daniel was saying.
Wow.
He said, yeah, that's extraordinary. That's 10 times voltage output or around there, like he was claiming. That's actually more.
Follow Ohm's law. That's all I can say on that.
I had to change my scope probe, so 10 times. VRMS is showing 50 volts. And it says at the top it's 212 volts, which is more precise. The neon light is on with a slight blue hue, but he said it's not showing in the video. But this is the circuit that I'm going to be working on tonight, to see if we can get it built. And I'm going to show you the video right now.
So Ohm's law, voltage goes up, current goes down. Remember that.
But right, but you said what?
Sounds interesting. Awesome.
Oh yeah. No, what's really cool though is look at this waveform that he's getting. Look at that on the top. Doesn't that look familiar?
Nice negative spike. I
H-wave.
don't know how he did that. That's interesting.
Yeah.
H-wave.
That's exactly what mine looks like on the
it's not in
top.
the positive, like you don't have a.
Yeah, he said he's not using any tone generator. It's just the circuit producing that frequency.
What I'm saying is the Bedini SG does that, but inverted. It's at the top.
Oh, look at that board.
Yeah, so I do have the circuit here, and I'm going to put it in the preliminary guide for people, because this probably will be going in phase 2 guide as well. But yeah, he sent me the circuit.
It looks a lot like the Bedini circuit.
Yeah, it's a modified Jewel Thief circuit. I guess Jewel Thief is a Bedini circuit, I believe, right?
Yeah, they're all kind of like similar to the Jewel Thief.
Yeah. So, and he said he used they have, if you, it's hard to see in here. You can see it in the image that I'll share later. But you can see the transistor is a PNP. But he said he used an NPN, and he was getting that result, and it worked just fine. So we're going to try our NPN. It's an E13005 or 007 transistor, the one that Gerald recommended for his protection circuit.
This is the new Nunez circuit?
This is a modified Jewel Thief circuit to work with the coil. You can see the channel A and channel B there.
Coil, sorry, the POE, right?
Yeah. And this is utilizing, I'm assuming this is utilizing, I haven't looked at it thoroughly, but it looks like it's utilizing the Nunez method, the open circuit method.
That's what I was trying to tell you earlier, to pulse the coil with flyback, not with square waves.
Right, and this is a way
use
to
the square waves to generate the flyback and throw that.
Well, even having a PWM or a signal generator in the circuit is going to add a lot more, or is going to reduce the efficiency of the system because it's going to consume power, right? So what we want is a simple circuit to produce the right frequency like this. That's not going to consume too much, you know, maybe like mostly passive components, if that makes any sense.
Passive meaning not doing a lot of work, like just
Right, not needing a lot of energy to do what they're doing. Like it's not going to be a leak in the system in terms of when we're
So
measuring the
coil,
efficiency.
the coil would that's kind of saying the coil would have a lot of impedance to it, so it's not drawing a lot of amps.
But this is very good news, and I also have some good news regarding the version 3 432 coil he's trying to work on right now. And we've been going back and forth because he had to wind it a couple times, and we were looking at the photos, and let's see if I can pull this up. And I mean, I guess he had the same revelation at the same time I did, because I was looking at one of the photos and I, shared this with him, and he's like, yeah, that's kind of something that I confirmed when trying to wind this thing, is that there's 3 channels for the advanced version 3 432 coil, not 2. So there's 3 channels on this thing. And
wow.
And that's very important when winding it, because instead of going 1 over and 1 up, you're going to be going 1 over and 3 up, and you're going to be doing that 3 separate times, right? Because you're laying these down individually instead of in a multifilar.
Yeah. When you say multifilar, Ben, are you talking about 2 wires going
them
in?
Up. Yeah, twisting them up in the bundle like you see in Nathan and mine, in I's coil.
Yeah, you know what, Shawn? That term also confuses me, because it's like, yeah, you have
So
a multifilar. Is it in parallel? Is it in series? How many ends does it have?
So there's the kind of like a multifilar,
Wow.
where it's like twisted together.
Is that Litz wire, or is it just one wire going in, the other wire coming back?
So I'm not actually sure
That
how
would
he
be a
did this
series
one.
wind.
This is something unique that he's working on, I think.
It looks
I
like a
haven't really
series
asked him
wind.
much about it.
Yeah.
But he just, he graciously shared what he was working on with me, and I found this very fascinating. I'm not actually sure how he wound this one, though. I think
it's series, Ben. It's a series wind. It's multifilar, but you have.
But you have
they're all put in series. All the filings.
Yeah, I think you're right, Mike. And then I think that's all the pictures I have from him. Do I have another video?
It's a lot of
That
work.
would give you an extremely high voltage, and it'd be easier to wind that up and build it in a multifilar fashion rather than one piece of wire.
He got the induction working. He got it working as a Tesla coil pretty much, and this is something that I was working towards, but I didn't get around to yet.
Yeah.
And as you can see, look at this. This is with the modified Jewel Thief circuit. He's using the big coil as a driver.
Oh.
Primary coil, and then the small coil is just. He said the field is about 2 feet, so
Nice.
it's like a Tesla coil. You don't even have to sit it on top.
Exactly. Yeah.
It's so cool, and those are high voltage, I believe. Right?
I mean,
yeah, look at that.
I mean, he's probably getting like maybe, like you said, hundreds of volts.
Yeah.
If and the
But
reason
do you see how it's in the
getting,
negative, the voltage? There's no positive portion. Very little positive.
So yeah, in fact, what he's just doing too is he's doing wireless energy. So I'm curious, other than the coils, what are his other components? Was that the circuit you showed me earlier?
Yeah, just the modified Bedini Jewel
He's just
Thief
pulsing
circuit.
it like a standard coil would be pulsed, but because of the coil geometry, it's negative portion on the
sorry,
spike.
Ben, I couldn't hear you. Ben, I'm sorry, I couldn't hear you. What was that?
Oh, no, I was just saying, yeah, he's just putting power into it. He's not putting a tone into it or anything. That it's just connected to the Jewel Thief circuit. That's it.
Where the oscillations come from?
I'm assuming the frequency comes from the circuit and the components in the circuit.
Yeah,
He doesn't. Does he? He doesn't. His load is the LED.
Yeah. The There's another video I haven't had a chance to look at that he sent me as well. I'm gonna put it up.
I don't know if you can get a reading when the LED's hooked up. He probably did that reading when the LED was disconnected. He was reading the flyback.
Wow.
Yeah, like
reading the
you
coil
said, Mike.
output.
There's a big spike on the bottom.
There it is. That's
It's
the
it's a
neon.
different. Yeah, it's a different
That
waveform.
bulb is the
If it works
NE-2.
like
You need to get some of those, Ben.
right, but the important thing here is that that's the waveform we're looking for the Nunez method, 10
Yeah.
times voltage output.
That's-
right?
that's the
I was
radiant
not
spike.
able
That's
to
what they
find
call
that.
it.
That's
Wow.
what, and he
The
found
flyback.
it, and that's what we're going to be looking for.
That's awesome.
They call
Yeah.
it flyback too.
You're doing something. It's basically you did a rodent Tesla coil. That's way cool.
Yeah. Yeah. And Mike's doing amazing work helping me trying to decrypt some of this. And this is going to be all great. This is all great news for phase 2 and phase 3 of testing of my coil specifically. So
that's
we're gonna have a
great.
lot of fun with this, guys. And the revolution has already started. There was some talk saying, like, I had some word around the campfire saying, it's impossible. We're never going to inspire people to start building these devices, and we already have. So
Yeah,
it's happening.
I know. I have a one I'm winding right now.
And I get contacted every once in a while by somebody new saying, yeah, I'm working on this. This is cool.
But the thing I'm trying to say is you could feed a coil two ways. You could feed it your signal, your square wave, whatever, or you can feed it the reverse signal that a coil creates called flyback, and take a signal from one coil, flyback signal.
Yep.
And send
Peter
it
said
into
you can do
another
that with
coil.
a pancake coil. That's kind of like basically what this is, Peter. It's a different version using more of a sacred geometry, though. But that's basically what they based Daniel and Erica Nunez patent is based off of the pancake coil by Tesla.
Yep, you can see it. You can totally see it because Tesla's pancake is a bifilar and it's high voltage.
Yes, he was onto something by twisting those wires together. There's some kind of induction method going on. I don't think I fully understand it, but it's drawing in extra energy from the vacuum somehow.
Well, the more
awesome.
turns the coil has, the more pressure you need to give it before it blows up. The more pressure the coil can handle, and the more pressure the coil will build. And when you release your pressure from it, that pressure comes back inverted, the same amount of pressure that you gave it. So that's why when you have more turns and more wire, you get a bigger spike, a bigger peak on the voltage of the spike. The peak of the spike peak voltage is greater, meaning, not 300 volts, but 800 volts. The more, but if you're, keeping the gauge the same, you can't change the gauge here. When I talk about 100 foot of wire, one gauge gets you a 300 volt peak, and 100 and 500 feet of wire of the same gauge gets you a higher peak.
Right.
Actually, that's reverse. That's why Tesla coils have a thick wire primary and a skinny wire secondary.
No, I'm saying the same gauge. 100 feet of the same gauge gives you 300 volts, and 500 feet of the same gauge gets you more voltage, because it's more pressure. The coil has more resistance.
Are you talking about turns of wire? Or are you talking
The more
out?
impedance the coil has, the more pressure it requires.
That's correct. There's a rule of thumb, Ben, and Mike already knows this, but
Ohm's law.
if you have one wrapping of wire on a primary, and you have 10 wrappings of wire on the secondary, then you're going to get an increase of 10. It has to do with ratios.
I think this is, and I don't know if you guys feel the same way, but I think that's why the rodent coil makes a perfect addition to the Bedini SG or Bedini circuits in general, because he's using, the traditional step up method for transforming the energy. And this is using sacred geometry, which transforms it on a 1-to-1 ratio and utilizes that extra energy. So I think I feel like this is like the next step in his circuit designs here is adding the rodent coil. I think that's the end result for maximizing the efficiency of his system, in my opinion.
I agree. I think you're
You know
honest.
what I
there,
think the
Ben.
rotated coil is doing is, since it's got that geometry, it's creating that extra negative portion in the spike, which I don't see in a standard coil.
Yeah, you're right, Mike. It does. It creates that extra negative, like you saw in the waveform of Mike's oscilloscope. It's like huge spike on the bottom.
Right, and I have a video where I'm using a standard coil, and it's the same waveform, but it's at the positive side.
Oh, huh.
You're not hearing me. I'm
I
saying
wonder
the
what we
negative
can
side of the
infer from
spike
that.
is way down there. If you look at the signal, I've never seen that, not in my lab.
Yeah,
not with
we,
any
we get
coils that
some
I've
weird,
ever had.
we get some weird stuffs on the scope, man. I'm seeing.
I mean, all that negative spike portion was that's interesting. You can do a lot with that. I mean, you can do a lot with the positive spike portion too, because it also has a small negative portion with it, like you see in his signal here with the small positive portion that you can see in the spike. There's a small bounce in the positive above the zero line, but most of it's below the zero line in the spike in his image here. That's got to be the coil, the geometry of the coil. In my opinion, that's what it is.
I agree. Hey, Ben, Mike, do you guys mind if I go through the questions here real quick in the comments? Just don't want
Go
our
ahead.
peeps to feel like they're not being answered. Thank you.
Yeah, every once in a while we forget to pay attention to the chat. We get so engaged. Right?
I know. I do the same thing. Thank you so much, guys. So I'm sort of in the middle here, but I seem to see some questions. Let's see. Resonance, in my experience, is the smallest input versus the biggest output. Johan Reader, that's a good way to put it. My favorite way to say resonance is that it's the least dampened frequency or the least dampened signal. I heard that somewhere, and that was a really good description.
Right, I like to
Ben?
think of
What
it
do you
as
think's a good
no
description?
signal attenuation.
Perfect. How about you, Mike?
Right, you don't want any feedback coming in. Well, if you have any feedback, it's going to be the flyback, obviously. If you have, you're not going to have any feedback if you're utilizing the flyback or throwing it out.
But there's no flyback in the ZBS, so.
I didn't know you guys were talking about the ZBS.
Just resonant frequency is where the least attenuated signal. I like Ben's
Right.
too, or least dampened.
You're going to get attenuation when you have feedback. Right.
Yeah. All right. Looks like we have another question here. Let's see. Look for high or HFE current gain values on BJTs. Results in sharper on-off curve slew rate for good spikes. That sounds good for some of the circuits.
Where are you reading this?
The comments on the right.
Up higher or something?
No, toward the bottom. Peter Half Effect says bifilar pancake coils work a lot like that. So yeah, just like when Mike was pulling his smaller Rodin coil to his larger one, it works just the same way as a bifilar or a Tesla coil. Let's see here. Wizard of Woodstock says Jewel Thief is blocking a blocking oscillator. I'm not familiar. I'm not intimate with the Jewel Thief, so I'll have to look into that. Thoughts, guys?
I couldn't. It must have been a trick question. I couldn't get it. Where are you reading though? I'm trying to find where you're reading.
Wizard of Woodstock. Jewel Thief is blocking oscillator toward the bottom.
I'm not seeing nothing. Why am I not seeing?
Are you switched from private chat to comments up in the right hand corner?
I'm in comments. Yeah, it's just not. All I see is LCR meter from Wizard.
Maybe you need to reboot, huh? Maybe it's stuck. Bernie is asking Shawn, please show the coil you are winding. I don't know. Should I? I'm winding many coils.
Show it. Show what you got.
Scroll up.
Oh boy. Can you guys chat for a bit? I gotta go pull up my latest coil real quick. I'm almost through the chat here if you wanna take over, Nathan or Ben.
So
Yeah, I'm
Nathan,
here.
I was gonna say this modified Jewel Thief circuit. It seems to be good news for our bigger coils. We might be able to get them to work with this thing.
The one you're looking at?
Yeah, hopefully, I'm hoping at least. But that's, I mean, he's using a big coil with big spacings, you know, to as his primary coil. So I'm kind of excited about this. I think we can do it now with the Joker and the Fireball.
I can't wait.
Yeah,
I
this
agree.
is cool.
Yeah, what is this circuit for, Bedini?
Yeah, it's a modified Jewel Thief circuit to work with the rodent coil. So you can see channel A and channel B there. And I believe it's using the open circuit method. I haven't analyzed it thoroughly because I'm not I can't sight read circuits yet, but it looks to be using the open circuit method. And he put in 14 volts. And
What I see here in the
220
circuit is the primary
milliamps.
battery is triggering the transistor and loading the secondary or the other coil. I don't know if it's a secondary, but you see the one coil on the left is being used to create a trigger signal to the transistor to then send power from the same battery to the other coil on the right to create your high voltage flyback, which will then simulate AC because it reaches over 120 volts. And AC devices will run off of that signal as long as it's got some decency to it, I guess, and it's not too high a voltage. And you know, if it stays around 100 to 200 volts flyback, it should run an AC device because it's not a lot of amps in there. You know, it's not going to run an AC device that has a huge load unless your MOSFET can speed up the frequency and on that spike signal. Or yeah, these Jewel Thieves, I built one. I made out of a Makita case. I put it in there for a hurricane that was coming up, and I actually used it when the power went out, and it was impressive, man. That thing was lighting one light. I just used it for light every night on lead alum batteries and that fit inside the same case, and it ran for like 2 weeks. That one light, it was like a 7-watt light or something, and I had it running about 4 hours a night, 5 hours a night, and it
the
just
power
kept running.
source on that.
It never went out actually. Before the power came on, the power was off for like about a week and a half, I think.
You have like a 12-volt battery or something?
It was like 3 6-volt batteries, lead alum batteries, charged that way. You know, not a dense charge either. You know, 18 volts. It was running it with 18 volts, and one, you know, around a nice big piece of ferrite core. That was one thing I could say. The core spanned the case was about 1.5 feet wide. You know, your standard drill case or whatever from Makita, and it was about as wide as the case, a little bit shorter, so it could fit in there, and I could close it. I had a plug facing out on one end of the case, and a switch, and yeah, I still got it.
All right, Ben, is this PNP you're looking at?
So it's PMP, but I asked Michael about that, and he said he's using an NPN.
That's a PNP drawing.
Yeah, and he said he's using an NPN and it works fine for him.
Well, it changes the flow direction of everything. You know that, right? Because when you start looking at the transistor here, the arrow on it tells you which way the flow is. So a NPN would be opposite. It'd be on the top. So
yeah, the emitter and the collector flipped or whatever.
30557 MJE.
The positive goes through that first coil, meets the base of the transistor. The negative of the battery meets the emitter of that same transistor to trigger it, and it takes time for the positive to go through that coil and the resistor.
What is that little line going through the resistor symbol? That little arrow. Does that mean anything?
It means it's a diode, or excuse me, it's a light LED. It's a LED diode.
LED. Oh, okay, so that's one of those high voltage LEDs. or is that
what to the left on top of the battery?
I'm trying to figure out what kind of component I need to put there. It says
That's
100K
an amp meter.
pulse.
Oh, hold on. Let me look at it again. Just give me a second. I'll probably pull up a chart. I'm trying to find this thing first.
Oh, I see. Yeah, no. I see the amp meter though. It's the one connected to the base of the transistor. I'm trying to figure out what that is. It's a resistor.
Oh, that's a potentiometer.
Oh, potentiometer.
What is that? I can't see, but
100K.
yeah, that high resistance.
That's how you tune it. Yeah.
Well, you don't let not too much current go to the base, because if you do, then the collector emitter is going to pass about 10 times the amount of the current that you gave at the base to the emitter. So whatever.
Right, but I'm thinking because I watched a video with Daniel Nunez in the circuit, and he has a potentiometer, and he's trying to adjust it to find the sweet spot.
Right. The sweet spot for the battery to be handle a load for that coil is what that is. You don't want too much
resonating
current.
with
You want that battery to be comfortable with the coil and the amount of energy the other coil is demanding on it each event of the switch. And the battery is part of the resonance here. The whole circuit has to be in resonance, not just the coils. Even the transistor, you can't overrun the transistor.
Okay, it says NPN on it for what the model number is. So
Yeah, I can't. I need glasses.
No, it's fine. Ben, this is just basically throwing resonance back on top of each other for each coil. That's all this is.
Okay, so it's feeding it back into the coil.
It's not much different than Gerald circuit.
Yeah, I know. I think Gerald mentioned that he did use a modified Joule Thief, so this might be very similar to what he's using. Yeah.
Yeah, because all you're doing is redirecting the flow back into the other coil.
I mean, if you notice the flow,
Right, and you're using the potentiometer to find the sweet spot of the resonance, right?
Yeah, that's a potentiometer, I think.
Okay.
Yeah, that is a potentiometer. I'm sorry, I can see it now.
It's
There's
okay.
a resistor and then the arrow, so a potentiometer.
if
And
you
it
notice
looks
the
like
positive of the battery, it's on the left there, flowing up the top of the
100K.
coil down, and it comes back up from the other coil up in the opposite direction. That probably plays a role in the self-oscillation of this thing, getting it to self-oscillate without a capacitor or nothing like that. I don't see a capacitor there.
Now the only difference is the two coils here, they're not set up how Gerald's is.
And what I'm saying is the flow
They're
of
not set up
energy
the
is
same way as
going out
yours,
the
Ben.
battery on the left side. The plus terminal is on the left. It's going on the top of that coil, down the coil. And then once it triggers that small amount of energy going down, triggers the transistor, goes out the emitter. But once that transistor closes, then the energy comes up the other way, up the other coil, not down. It goes up, I think. I'm looking at it here. You see plus. Then
No, the flow path is right. It's
yeah, it goes up because you see it's tapped to the positive there to feed the other
You
coil.
see the two inputs, the
The
start.
flows are in two directions on the
The
two
two
coils.
starts of the coil are connected along with one of the ends of the channel B of the coil as well. All three of those ends of the coils are connected to the same line.
If you follow the positive terminal of the battery, you see that tap going on the top of the coil in blue, where it says blue, that wire pointing down, and it goes across the other side down, and it goes back up the other coil. So the positive energy is going up, not down, up on the right side of the coil. And the energy is going down on the left-sided coil. The positive energy from the battery is going down on the left side coil.
Oh, I see. Yeah,
right
no, you're
side.
right. It's not 3 points connected. It's the start and the end of the two channels are connected.
Opposite flow.
Yeah, the start of the blue is connected to the end of the brown.
okay. So
Yes.
look, the only thing you need to know is that the potentiometer adjusts the resonance in the coil, okay, to resonate with each other. That's it. It's a self-resonant circuit. That's what you're getting here. Okay, that's what you get. Wizard of Woodstock is absolutely right.
Yeah.
Self-resonating. It's self-resonating between the two coils. The potentiometer controls the amount of flow so that it can do the resonating. And yes, it does work. Okay. So it is not the same thing as what Gerald had. Gerald is working with back EMF. I don't know that this one is at all. Okay, this is just resonance between the two coils.
Brown,
it's weird.
Brown, get this, if you could see the wiring, Brown has a constant 12 volts across it. I do remember that actually from replicating this. Brown has a constant 12 volts across it. Look at the wiring. The plus is constantly connected to the wire, and so is the minus. You'll see it.
Okay. All right.
It's
This
right
is more
there
like
in the middle.
yeah.
It goes down to the bottom, to the left.
So hold on. Let's just stop this madness right now. Ben, Gerald's got the circuit for you, the work, you got the parts. Okay. Figure it out.
Maybe I'm wrong.
Let's
Maybe that's
let's stop moving on to different circuits every time. Let's just figure one out and go with it. Okay. All these different circles will drive you nuts.
Take that back. There's a hoop over there. I couldn't see it. Yeah.
I
It's not
follow you,
connected. Never
Nathan.
mind. Never mind.
Yeah, I don't.
It's hard
I
to
don't like
see.
all
You got to
that.
maximize those schematics when you bring them up. It makes it easier.
Yeah, well, yeah, I could see it very easily. Yeah, it's just a big confusion, especially if you
good
don't
for you,
understand the
Nathan.
circuits yet. It's just piling the crap on top of your head. It's just not helping. So
I was actually referring to me, so I could see it better.
no. All I'm saying is stick with one circuit, get it to work. Then you can move on to the next circuit, but don't jump around.
Yeah, I actually got the Joule Thief working. It's not that hard to build. It's very
I'm
easy.
almost there, Nathan. I'm transferring some pics.
Right on.
Now that you taught me how to share my screen, I can start pulling stuff up. Awesome. Yeah, you taught me a lot today. I appreciate it.
Oh, you're welcome.
I'm going to be a pro here. Ready to finally start my channel. Oh, my goodness.
Well, trying to get you there, man, because everybody wants to see your stuff.
I appreciate it. I feel like this opportunity you've given me here is really breaking the ice and kind of teaching me the ropes. So I really appreciate these Wednesdays you let me share. And thank you too, Ben.
Of course, anytime.
So
Time I'm going live, I usually send out invites just in case anybody's available.
I just saw yours, Ben, in the email. I apologize. If I had a little bit more of a schedule heads up, I definitely wouldn't mind joining. I like the stuff that you're doing.
Oh yeah, you don't need to apologize. A lot of the stuff is last minute. That's why I send out a lot of invites because I expect not a lot of people to be able to show up at last minute.
But when I can, I do though.
Hey, Ben, I missed that email from the Rumble stream. I got the email
to the
late.
Rumble stream. I thought I did.
Yeah, it was yesterday.
That's why I didn't see you there. I was like, where the heck is Mike? I'm pretty sure I sent you an email.
No, I got the email, but I don't know. I think I was sleeping or something, or just didn't see it in time.
Oh, you missed it. Oh, okay. No. I was like, where's Mike at?
Rumble.
I don't know how to use Rumble.
It's
I
all
can't
free.
figure it out.
YouTube's free. Rumble. I think Rumble though is better.
Every true wizard has a voltage doubler. Victor
If
just
you're gonna
said
start a channel, Shawn, you don't want to want to start with YouTube because they're censoring everybody. That's what I heard anyway.
I don't know how to use Rumble.
It's okay. What Shawn does is not going to get censored. Trust me, he's good. He's building testicles and circuits for him, and you know what I mean. He's good.
Thanks, Nathan.
Yeah.
Or whatever, the copyright strikes and all that. Does Rumble do that too?
Yes.
Oh.
So
nothing exciting. I'm just going to move my current coils here in a folder, and then I'll share them with you guys. Just a couple things that are on my shiny new list. And it's just coils. I'm not going to get into the circuits yet because I feel like we've got a lot of circuit overload tonight.
Yeah.
Ben, any good questions in the chat?
This guy asked, are you guys on Rumble? We are on Rumble. Nathan and I both have a Rumble page, and I know Bernie just created one as well, the Crypto Alchemists. I think it's linked in the description. Let me make sure. Nope, we'll be posting those in chat momentarily.
Oh man. Anyway, all right, Shawn, you got that thing about ready to present?
Yeah, just sorry, not 1 minute. Almost done.
If you need a few minutes, we can play an episode of Cracker Jacks.
What? Oh man. All right. Well, this is what I got. If you don't mind, I'll share my screen or
Yeah, do it. I'll
share
put you up.
my let's see here. Oh boy, you just taught me this. Let's see. Okay, here we go. All right, I'm going to go to present and share my screen. Let's see, entire screen. Make sure nothing's personal showing up. Okay, good. Oh, I forgot to do that one thing. Sorry. There we go. it's a lot. All right, here we go. This is where my dyslexia is my worst enemy. Okay, can everybody see my desktop? You guys see my bank account info and all that?
Yep, got your password.
All right, so I'm in the works of 3D printing this. It's going to be basically a donut jig, but I'm going to use it to create this exact pattern. I think it's in the rodent family, but I'm going to have something close here pretty soon, but this is how I'm hoping to wind it. I guess it's kind of a vortex coil too. What do you guys think?
Yeah, well, it should definitely do that magnet.
Well, it's going in two directions. Wait, you got two vortexes.
Yeah,
two directions.
Awesome.
You do have an interference pattern there, so you're gonna have two counter-rotating fields.
That sounds great. Way cool.
What do you expect to happen there? Cancellation or something else?
Black hole. I want to create a black hole.
They should condense on top of one another to create a desktop black
answer.
hole. Yeah, vortex coils do that.
We like talking about holes.
Oh,
This I just got this cleaned up out of the 3D printer. It's actually an iridescent gold, so this picture doesn't do it any credit. But what I'm doing here is I haven't decided yet. Litz wire or soldering the ends of the Litz wire, so it's one wire, or using like a spool over here to the left and coiling until I lose my sanity. So I haven't decided yet, but I have a whole new respect for people who wind coils like this. Ben, huge respect, because this is crazy.
It's a lot of work.
I had to wind one that was literally maybe 3 inches across, like a small one. It was very hard.
You can end up in a madhouse building one of these things.
It's funny because it just like springs open and you lose all your work. And I know super glue helps, but
it's basically how I did it with the small one. You have to super glue it, but I didn't use super glue. I used UV glue because it's easier to remove if you make a mistake. But it's solid enough to help you, you know.
Good points. Thank you. Also, Nathan's a natural coiler. It makes me sick.
Yeah, I love his Joker coil.
I do too.
You already built a vortex coil, Nathan?
Like Ben's?
Yeah.
Yeah, I did.
You did? I didn't see it. I never saw that.
Oh, here, let me move some of my stuff. I'll grab it for you.
Yeah, his glows in the dark. It's really neat.
So
well,
this is
I thought that was the frame for it.
Yeah, the frame does.
So can you guys see this next slide?
Yeah, that looks like the Death Star coil frame.
Yeah, this is sphere number 2. So this is version 2. It's the iridescent gold because I like the print, and I'm doing it on 33 gauge instead of 32, so I should get a little bit higher voltage. So I can't wait. I'm excited to finish that one. There it is in its form. So a lot of sanding. A lot of people think you could just print this and go, the spheres, but no, you could see it kind of has a rough look. It needs to be glued straight. It needs to be swept through with a piece of sandpaper, and it's all labor of love. But this is a complex thing, so it's not just going to print the first time. So I think that's it. I think that's, yeah, just a handful of coils right now. Thanks for letting me share.
Thanks for sharing with us.
Appreciate it.
So for those who don't know, this is my coil.
It's so cool. You got to show it in the dark.
Yeah, well, I didn't put it outside to charge up yet.
So it's huge.
Yeah.
What's the diameter?
It's the same as Ben's, kind of the same size.
Yeah, same exact size as the Fireball.
Yeah, yeah. So they're twins. They're twin coils. Only.
Yeah,
you mind if I ask how long that took?
It's insane.
This thing came out, by the way, in 20 gauge. Is the best look for this thing, and it's thick and it's nice, and I could push a ton through it.
Yeah, I like the fact. I think 20 gauge is probably more of a fit for that coil size. I use too small of a gauge for sure for that frame. I might have to rewind it.
What'd you use?
But I will. So I used the 24, but that's all I had available, honestly. So
just means you have to wind for a whole nother half of your lifetime.
Well, I was planning on rewinding it anyways at some point, but you know, if we can get it working, you know, who knows? Maybe I'll keep it the way it is and just make a new one. You know.
Sounds good. All right, gents.
Yeah, it's getting late, guys. So look, Mike, you got that video? We're gonna play it on the way out, and when it's over, we're done for the night.
Yeah, give me a second. Hold on.
Hey, great seeing y'all and spending time with you guys. Great to see you. I'm just going to put myself on mute for the video. Thanks, Nathan, Ben. Thanks,
hey guys,
Mike.
thank you, Shawn, for showing up and doing everything. I really appreciate it. And well, I'll see you to probably talk to you tomorrow.
Awesome.
Thanks, Shawn. We appreciate you.
Awesome. Thank you, guys. I appreciate you guys. Bye.
Mike, this is the captain speaking. Have you and Ben been able to fix the transporter yet?
That's what I'm saying. I can explain to you very simply how to verify if that ground, the third prong at the bottom, the circle hole. I think it's 3 prongs, right? 3 holes. You're in Canada? I don't know.
No. It's 3 holes, yeah.
So you have the ground. The third hole is the ground. So you could test that ground by. You have the 2 other holes. Are they the same size or is one bigger?
I'm sorry, say that again?
You have you have 3 holes. One is ground at the bottom, and the 2 that are at the top are the power. Are they the 2 holes? Are they the same size, or is one bigger?
No, they're the same size.
Same size. So it's 2. You're in Canada?
No, Michigan.
Michigan. So it can't be the same size. One slit is a little shorter.
Are you sure? Let me see.
Look closely. You need more light in there.
Oh yeah, you're right.
I'm sorry, Mike. Did you say you had the transporter fixed?
Put the voltmeter on AC 120 volt setting. Put one prong in the ground and the other prong in the smaller hole. That's your hot line. And if you get 120 volts, that ground is working good. If you don't, you get less than 120 volts, like 90 or 80, your ground is probably no good. on that plug. That could cause a lot of issues for the circuit too, by the way.
Well, the problem is this only goes up to 10 amps and then it blows.
No,
so-
you don't need amps. You just need 120 volts. Is what
It
you should
blows.
Okay. As long as it doesn't blow my fuse.
Put it
I'm
on
good.
volts, not amps. Volts. 120 AC volts.
This
Oh.
should be this should be good to 250 volts, so we
Oh.
should be okay.
Hey, Gerald, come here and listen to this. I can't tell if they're fixing the transporter or not.
Right. So now put one prong in the ground, the other prong in the smaller hole, not the bigger one. The smaller.
Does it matter which one is which?
It, no, that's too much. It kind of does matter. But anyway,
Wait, so the red
of the two holes, other than the ground hole, of the two holes that you have there, one is smaller. That is the smaller hole is the power. The bigger hole is the return for that power.
The negative. Okay.
Yeah, you
So-
don't want to use that to.
All right.
check
So
this out. You wanna
real
check
quick
the
before I
power.
electrocute myself, Mike, which
You're not going
hole do I stick this in?
Don't stick the plug out. Just stick the prong.
If the hole is red, there's
God.
something wrong.
The probe has two prongs, two metal.
I'm sorry.
Put
This
one
got
prong in
really-
the ground and the other prong in the smaller of the two holes that are left.
But it doesn't matter which one is which.
No, it does. One of the probes, you have two probes from the voltmeter. One goes, no, it doesn't matter which one of the two goes in the ground. No, it doesn't.
Okay,
Answer
so I
your
can put
question.
the black one in the ground and then
Yeah.
the red one in the
Yeah.
small slot.
Yes, yes. Sorry, I
Okay.
misunderstood you there.
No, it's okay. We're talking about putting things in holes.
Yeah, easy to
It's your
get.
probe then prefers a certain one.
So yeah, if you don't see a 120 volts right away, just wiggle it around till you get a good connection. You just use 120 volts or like less than that, like maybe
It's just
100
too
volts.
easy.
Yeah, 120.
Okay, your ground is good. You just verified it. It's good ground.
Nice.
Now, just so you know, if it read less than 120, like around 100 or 90 or 80, that ground is no good.
Oh,
Right. Okay. It was actually slightly above 120. So is that normal?
Yeah, you're
It's like
good.
120.
The ground is good. Good. Just make sure you're firmly connected to that third prong into your circuit.
something tells me we're never getting this transporter fixed.
If you were to put one prong into ground and the other prong into the return, you wouldn't get anything because it's not source. You're not hitting source. You want to go from ground.
Oh my
from
God.
source to ground to get it.
Oh,
No, that makes sense. If you're
Oh.
not properly grounded, you're going to be getting a loss.
You're right, Nick?
yeah. Oh my Jesus, guys. That is so great. Guys, thank you for hanging out with us tonight. Mike, thank you for being such a good sport about this, man. It's so amazing.
Thanks for having us on.
Thanks, man. See you, man.
Later,
See you
Mike.
guys Friday.
Yeah, I'll see you guys for Free Energy Fridays.
All right, guys. Yeah, see you on Friday. Have a great night. Thank you.
Chat. Thanks, Nathan. Later, guys.